Hi, welcome to another video on my Raspberry Pi. Connected with a flat cable to a breadboard with electronics and some fischertechnik motors. The motors are pulse width modulation driven, and if you have watched my previous videos more recently, you have seen that I've tried to control them using pulse width modulation, and so far when I control them the motors run, but just not really controlled by pulse width modulation. I measure it, and let me see. Here you have one motor running, and the other motor can run as well if I turn it a little bit higher. Then it runs very slowly and stops. However, the code that I've written using the pulse width modulation library has the effect that I can measure it with the frequency, but it has little to no effect on the motor, as I already said. The motors, being from fischertechnik, can be controlled by one of those power controllers, and then you can actually really control the motors. So I've taken one of those controllers, put it on, connected it to a multimeter, the same one that I've used recently, and then this shows up. So the setting is right here, and if you watch the display, I can turn it all over from 0.04 to 0.11 and 12. Keep in mind that the setting is 20 kilohertz maximum, and the setting is in kilohertz. So this is not, of course, then 120 hertz maximum. So what I have to do is saying, okay, the controller goes from 120 hertz maximum from 40 hertz. So that is actually the range I should measure on my breadboard in order to be able to apparently control the voltage. However, what I also should keep in mind is that the input voltage is 9 volt. So that in combination with the pulse width modulation should give the desired effect as well. So what I will do is to keep the voltage going, and then try with frequencies in order to get it really in control. So that's the focus of this video. So with this knowledge in the software range or in the frequency range, I'm going to measure once again on the breadboard. And for this to help, I start also the program written in C. And then I have to enter a value, so I start at 1. And let me see which frequency belongs to that. So first a probe at mass, and that is 1.6 kilohertz. Then we take the other end range, 1024. Once again measuring. That is, well, let's say 0.7. So and with that, it turns out that I have to do something about it, because the range, as I measured with the power controller, is way lower than this range. It is 4220 Hertz, and the lowest frequency now is with the current 1024 number is 700 Hertz. So let me check one more value. Here the mass, and let's check here then. That's 15 kilohertz. That is way too high. So there won't be any effect at all. Now what I can do is because I was running at full speed, so now I have lowered the speed quite a bit. Let's see what happens now. Once again, this is 14 kilohertz, and this is quite the opposite. It's well varying between 90 Hertz and 300 and whatever 500 Hertz or so. So that's actually lower voltage. So let's say this is the former two measurements were at full range, full speed. Now low speed, still 1024. Measuring once again, make no mistake, at this place. .9 kilohertz, and at the motor it's 10 kilohertz. And let me enter now pulse width modulation 1 again at low speed, see what that brings. 1.5 kilohertz. And at the motor, at this motor, still way too high, some 10 kilohertz. So I have to go to the code to see how I can bring that back.
Okay, so let's clear this. And go back to, I've been checking out some stuff, and my suspicion or my ideas are quite correct. As concerning the value, the higher the value, the lower the frequency. So what I am going to try is regarding the fact that the value of 1024 gives about 0.7k kilohertz, which means 700 hertz. That's way too high, so for my usage, so I'm going to change this to 2084, and then I hope that the value is low enough. Changing this range, well, actually this is just command, so I don't and this as well, although of course since I can enter the values by hand, it's no problem. So let me just quit the code, enter them again, and I just have to enter the range here. So I will do 2048 and then see what frequency it gives. 2048. Then probing the mass again, and the motor gives 1 kilohertz, which is not what I expect. Probing the mass and the other motor gives about 200 hertz, which is still way too high, which might indicate something that I don't like. And now I'm probing again at the motor. It says 1.4, between 1.3 and 1.4. This indicates that giving a higher value than 1024 doesn't matter. So I'm changing to 1024 now. Oops. And I am getting 1.4. That means that this value, the range, is set hard. And when I interrupt this program and I go into RaspberryPi, I have, if I am correct, let me see. Here I have wiring pi.c. So let me exit this code, go to wiring pi, and then of course this is the directory, so well, this is the actual code. And now what I need to do is finding the range. Block size definitions. This is the first time I look into the code, so I really have no idea what I will encounter. Although I do see here, of course, 256, 512 and 1024. The rest is 0. And the question is, how do I increase the range? And that is quite a challenge, of course. But I need to do that in order to get the frequency on the board low enough to actually be of any influence to the motor. These are just revisions. These are memory sizes. So actually with this code I have to find out what I need to change. And in order not to bore you too much, I will do that offline. However, this means that in the current situation I cannot get into the range that the fischertechnik motors require. And I will see what I can do about that with this. After looking into the documentation, and that is primarily here at the wiring PI information, it gives information that the minimum pulse width is 100 microseconds, which gives a frequency of 100 Hertz. And when I look at my data with the power controller giving a frequency range from 40 Hertz to 120 Hertz, that is a range in which the 100 Hertz from 100 microseconds is perfectly fitted. However, with my current setup, full range of 1024, I get 700 Hertz at the lowest. So without changing the wiring PI driver, it should be possible to get 100 Hertz. The question is, should I change my electronics? And when I go back to this information, let me get this example. They show an example with a resistor of 330 ohms, and that is something I may have to change, because my resistors are not that value, and in order to get the right resistor value, resistance, I have to experiment with higher or lower resistance, and I hope that I will then get to my desired frequency of 100 Hz, or the range of 40 to 120 Hz. Right now it's absolutely unsure if I can get that, because if I look at the electronics, I have no less than some 4 resistors in place, and the issue with resistors is if you put them in series you add them, if you put them in parallel you divide them. So I have no idea if I have place enough in the circuit, although the breadboard is big enough, but I have to wire everything. So that is going to be a challenge. But in the current situation, this is the new challenge, getting a resistance value that is working. Other than that, this code which I showed before of wiring PI, I am staying off it for now, just to see whether the word is true, and I have no reason to doubt it, but electronics can make a big difference. So let's just see if that helps. Alright, so with this electronic circuit something has to change, and that is with respect to the resistors. Now those resistors are 188 ohms, 188. So if I put them in series, they deliver twice the resistance, which is 360, which comes very close to the example on the website. So what I will do at first is change here and put a resistor in series. And I will do that like this. So that is one, and now another one just alike, bending closely, one here and one just shoot in the middle of the transistor. So with this result I should be actually hoping on a better result. So
I am going back to the program, start it, and I have to put the highest value, 1024, and now it's time to measure again, see what has changed. And now it's 900, which is virtually no change. 800, 750. So that is no change. And there's still another resistor here. So I will put a change here. See if that helps anything. And let me put this one here. So I changed this one from here to here. And this resistor is going from here so now I have put another resistor which are the same. So let's see what the difference that makes. Once again, probing here, probing here, oh, that's a big change, but in the wrong direction, I think. This one is higher, over 1 kilo ohm, over 1 kilohertz. Oops. So let me change this back. Measure again. Measuring here and measuring here, and that drops the frequency. And I will put the multimeter there so you can watch closely. So where does the solution come from? Maybe here, maybe I should change resistors here as well. I'll yet have to see, but for now it's in the solution is in electronics, that's for sure. So thank you for watching, and to be continued.